Good morning, everybody. Hopefully you're watching this video on Thursday, January 18th. If you are, it means that you're all caught up with the classroom and the pacing procedure. And so this is going to be the second part to the 4.2 notes you already started, and that's regarding solving inequalities using addition or subtraction. So we're just using addition or subtraction right now, so you're not going to see any multiplication division until 4.3. But if you understand the concept of using the inverse operation here, and then I think you will do just fine on 4.3 and anything else that follows after that, because 4.4 is going to be a combination of those two. So our essential question for these notes, these part of the notes today, is what is an inverse operation and how is it used to solve inequalities? Ooh, that's too big. Let's see. What is an inverse operation? How is it used to solve inequalities? Okay, so what is an inverse operation? How is it used to solve inequalities? So we're going to be talking about that in this second part as well, which is a follow-up to part 1 that you should have watched yesterday. And so we're going to start off with an example just to reiterate some of the stuff we were already talking about. That means reiterate means to repeat some of the stuff we've already talked about. And the example number 2 wants us to solve 13 is less than or equal to x plus 14. So we need to solve for x, and then we need to graph the solution. So solving for x in this case, I can see that I've got a plus 14 around the x, and so I'm going to want to get rid of that plus 14. So I'm going to use the inverse operation of addition, which is subtraction. And I'm going to put a note of that over here. The inverse operation of addition is subtraction. And so if I want to get rid of this plus 14, I'm going to use the inverse operation. I'm going to do minus 14 on both sides. I'm going to subtract 14 from both sides. And when I do that to both sides, I'm going to end up with a new inequality that looks like something like this. It's going to be, the sign is going to stay the same. But then on the left side, I have 13 minus 14 now. 13 minus 14 gives me negative 1. And then on my right side, I have x plus 14 minus 14, and that plus 14 and minus 14 are going to cancel out and leave you with just x. So we just solved for x, and we would read this as, I'm going to write this over here, I want you to write it as well. X is all values greater than or equal to negative 1. Greater than or equal to negative 1. So x isn't just negative 1, it's not just negative 2, it's all values greater than or equal to negative 1. So, and we're going to need to represent that. So we're going to find negative 1 on our graph. Negative 1 is right here. And then we're going to need to determine, do we need to use an open circle or a closed circle? Well, because x can equal negative 1, we're going to be using a closed circle. So anytime you see an equal sign, you should be using a closed circle. And then x is all values greater than negative 1. So if I were to have read this from left to right, it would be read as negative 1 is less than or equal to x. And so that describes negative 1. But what I'm really trying to describe here is x. So if I were to read it from right to left, I would read it as x is greater than or equal to negative 1. That gives me a better idea of what x is equal to. And the numbers that are greater than negative 1 are going to travel to the right this way. So I'm just going to put an arrow. Doesn't matter where you put the arrow. As long as the arrow is in the right direction, it'll be fine. And so we just solved this problem. We just graph what all of the values of x. So you've got some on your own to follow up, but I'm actually going to do these ones with you. So let's check these out. We are going to be solving the inequality and graphing the solution. So just like we did on that last one. I'm actually going to do number 6 and number 4 for you, but I'm going to let you do number 5. So let's start off with number 4. So number 4 says that w plus 7 is less than or equal to 4. So I want to get that W by itself, and I've got plus 7, so I'm going to use the inverse operation. I'm going to subtract 7 from both sides, which is going to leave me with my new inequality of, whoops, what the heck? Is going to leave me with my new inequality of W is less than or equal to, and 4 minus 7, that would be negative 3. So W is less than or equal to negative 3, or in other words, W is all values, please write this down, all values that are less than or equal to negative 3. W is all values that are less than or equal to negative 3. So if W can be negative 3, I'm going to use a closed circle at negative 3. And then W is all values less than negative 3. So that's going to be going in this left direction. Okay, let's do number 6 together. X plus 3/4 is greater than 1 1/2. I'm going to scroll down here to number 6. X plus 3/4 is greater than 1 1/2. Okay, so in order to do this, I'm going to use the same kind of techniques I've been using. I'm going to be taking away whatever is next to the x. So I got this plus 3/4, so I'm going to subtract 3/4 from the left side, and that means I'm going to also subtract 3/4 from the right side. So now at this point, you should see that anytime you do the inverse operation, you're always going to be left with just the variable if there's only one number around it. So I know that my answer is going to look something like x is greater than, and then now I need to figure out what goes on this right side. If I take 1 1/2 and I subtract 3/4, what does that look like? Well, I'm going to begin by turning this 1 1/2 into a improper fraction by taking the 2, multiplying it by the 1, and then adding it to the 1, and that transfers to 3/2. And then because they have different denominators, 3/2 and 3/4, I'm going to turn that 3/2 into a denominator of 4, which is going to give me 6/4. And from that, I'm going to subtract the 3/4. This 3/4 that we're subtracting here. So 6/4 minus 3/4, well, that gives me 3/4 1 again. And so that means that x is all values that are greater than 3/4 but are not equal to 3/4. So because there is not an equal sign, so really pay attention to that, because there's not an equal sign here, that means x cannot equal 3/4. It's all values greater than 3/4, but it cannot equal 3/4. So I'm going to go ahead and demonstrate what that would look like. I'm going to find 3/4, which I know is going to be between 0 and 1, kind of closer to the 1 than it is to the 0. And then I'm going to use an open circle because 3/4 itself is not part of the solution. So I'm going to use an open circle, and then x is all values greater than 3/4. So I'm going to move it over here to the right. And so that would be what all my values of x look like after we solved for x. Okay, so I'm going to let you do number 5 on your own. 5 is 12 and 5/10 is greater than or equal to d and plus 10. So I'm going to let you solve that on your own. Have me check it once you do that so I can tell you whether you got it right or wrong and you're understanding this concept. And then we've got one more thing. We've got this word problem, a real-life application. And the word problem reads, a person can be no taller than 6.25 feet, or 6 25/100 of a foot, to become an astronaut pilot for NASA. Your friend is 5 foot 9 inches tall. Write and solve an inequality that represents how much your friend can grow and still meet the requirement. So in this example, the words that we're given is we have the current height of our friend. So we've got the current height of our friend, and then we're going to be needing to find out what can we add, how much can this person grow before they reach the limit. So we're going to take their current height, we're going to add the amount that they can grow, so that's h. But we don't know how much they're actually going to grow. We don't know if it's going to be 1 inch, 2 inch, a whole foot. And so that's why we represent it with the letter H. And then whatever they do grow, in order for them to qualify as an astronaut, it has to be no more than, that means it can be equal to or less than the height limit, which is 6 25/100, or 6.25 of a foot. Now, as you can see here, you might have noticed that they did not write down the height as 5 feet 9 inches. Instead, they wrote it down as 5 feet and 75/100. So let me tell you why that is. So if you take a foot if you take a foot, it goes 1 inch all the way to 12 inches. And then if you break it up into 4 different parts, it's going to be separated by 3 inches. So it's going to go from 0 to 12. So this is going to be 3 inches, 6 inches, 9 inches, 12 inches. 12 inches would be a foot. Now, your friend is 5 feet 9 inches. So he's actually 5 feet and 3/4. So 1, 2, 3, 5 feet and 3/4 of a foot. And you might recall that 3/4 or 3/4 is, as a decimal, 5 75/100. And so that's why his current height is represented as a decimal instead of the 5 foot 9 inches, because the height limit was also given as a decimal. So you want to either make sure they're both decimals or make sure they're both in feet and inches. But in this case, the easier version would be decimals. Now I'm going to leave that there. Okay, and then so we're given the inequality, but now we need to determine on your own, your cousin is 5 feet 3 inches, so that's a different height. Write and solve an inequality that represents how much your cousin can grow and still meet the requirements. So you just have a different height here, but the question is still the same. So you've still got the same information as over here, but now you're given a different height. You need to turn that height into its decimal form. Just like I did over here, you need to turn that height into its decimal form and then write the rest of the inequality out. Hint, hint, it's going to be the same information as the top, but you're just changing this number. The 5 75/100 is going to be different for somebody who's 5 feet 3 inches. And then after that, go ahead and summarize what you've learned here for 4.2. So I want you to write at least 1 or 2 sentences of a summary so that that represents what you've learned, what you remember, something new that was for you. And so that way on your notebook check, next time we have a notebook check, you are also going to include the summary, and so you'll get those points for that. And if you have any questions on this, guys, please remember you can raise your hand. I'll come around and help you out. I'll help you out as much as I can, but I do encourage that you ask the people around you first, so that way I can be as efficient as possible for you guys.